SPSS Basics Day 2. Today I'm gonna answer some weird questions. How to type each of the given questions in SPSS: age, gender, education level, employment status, marital status, annual household income, geographic location, sexual orientation, religious or spiritual affiliation, household size, language proficiency explanation. To enter the given questions and their corresponding data in SPSS, you will be using the data editor. Here is a step-by-step guide on how to input this information. Open your data file, launch SPSS and open your data file or create a new one if you haven't already. Data entry. Click on the column headers on the data editor to select the appropriate variable where you want to enter the data. Enter data for each question. For each question, click in the corresponding cell under the variable you selected and type or enter the data. Here are detailed steps for each question. Click on the column under the variable name where you want to record each data and enter the ages of individuals. Gender, click on the column under the variable name where you want to record gender data and enter gender information. Male, female, non-binary, etc. Then education level, click on the column under the variable name where you want to record education level data and enter the education levels of individuals. High school, bachelor's, master's, etc. And employment status, click on the column under the variable name where you want to record employment status data and enter employment status, employed, unemployed, retired, etc. And marital status, click on the column under the variable name where you want to record marital status data and enter marital status like single, married, divorced, etc. And annual household income, click on the column under the variable name where you want to record income data and enter annual household income values. Then geographic location, click on the column under the variable name where you want to record location data and enter geographic location, city names, states, countries, etc. Then sexual orientation, if you want to include this option available, click on the column under the variable name and enter sexual orientation data. Then religious or spiritual affiliation, if you want to include this optional information variable, click on the column under the variable name and enter religious or spiritual affiliation data. Household size, similarly we will be adding. Language proficiency is same. Then for this variable, you might want to create a new variable for each language. To do this, go to transform, recode into different variables. Select the language proficiency variable as the input variable. Create new variables for each language you want to record. For example, English proficiency, Spanish proficiency. Define the recording criteria: 1 for fluent, 2 for intermediate, 3 for beginner. Click change to create the new variable. This should help enter your survey data into SPSS for further analysis. Be sure to save data file and to preserve your work. How to define data in here? In SPSS, defining data typically involves specifying the characteristics of each variable in your dataset. This includes defining variable names, variable labels, variable types, and specifying how the data is measured. Open your data file, launch SPSS and open your data file, view variable definitions. In the data editor window, you will see a row at the top with column headers. Each column represents a variable. The first row is typically where you define the variables. Define variable names. In the first row, click on the cell under the name column for each variable. Enter a short descriptive name for each variable. For example, age for the variable representing age. Define variable labels, optional but recommended. Then in the cell under the label column, you can enter a more detailed and descriptive label for each variable. This is useful for providing additional context. For example, respondent's age. Then specify variable type. In the cell under the type column, you can specify the type of data for each variable. Common variable types include numeric for continuous or discrete numerical data. For example, age, income. String variable for text data, names, descriptions. Date for dates and timestamps. Then specify measurement level. In the cell under the measure column, you can specify the measurement level of each variable. Common measurement levels include nominal, categorical data into, in the cell under measure column, you can specify the measurement level of each variable. Common measurement levels include nominal, categorical data with no inherent order like gender, racial status, ordinal. Categorical data with a meaningful order, educational level, income categories. Scale, continuous or interval data with a meaningful order and equal intervals, age, income. Then specify values for categorical variables. If a variable has categorical values, male and female or gender, you can specify the values under the values column. This helps SPSS understand the categories and their corresponding numerical codes. Then define missing values. Under the missing column, you can specify missing value codes for each variable. This tells SPSS how missing data is coded in your dataset. Save data definitions. After defining your variables, it is a good practice to save the data definitions by going to File, Save As. This ensures that your variable definitions are preserved with your data file. Then review and modify as needed. Double check your variable definitions to ensure accuracy. You can always go back and modify them if needed. Then defining your data in SPSS is essential for proper analysis and documentation. It helps SPSS understand the characteristics of your variable, which is crucial for conducting accurate statistical analysis and generating meaningful results. How we conduct ANOVA. Analysis of variance. ANOVA is a statistical technique used to compare the means of 3 or more groups or treatments to determine if there are statistically significant differences among them. ANOVA is useful when you want to assess whether variations in a dependent variable are predominantly due to differences between groups or if they can be attributed to random chance. Here are a few common scenarios and examples where ANOVA is used. Medical research example, drug effectiveness. Suppose you are conducting a medical survey to evaluate the effectiveness of 3 different drugs in treating a specific condition. You measure the improvement in a health metric, for example, blood pressure, for patients taking each drug. ANOVA can determine if there is a statistically significant difference in mean improvement between the 3 drug groups. Education example, teaching methods. In an educational research study, you are comparing the effectiveness of 3 different teaching methods: traditional lecture, online video tutorials, and interactive workshops on students' test scores. ANOVA can help determine if one teaching method leads to significantly different mean test scores compared to the others. Then manufacturing example, quality control. In a manufacturing process, you are testing 3 different manufacturing techniques to produce a specific product. You measure a quality attribute, product weight, for products produced using each technique. ANOVA can access if there are significant differences in the mean weights between the 3 manufacturing techniques. Then psychology example, stress reduction techniques. In a psychological study, you are investigating the effectiveness of 3 different stress reduction techniques for meditation, exercise, and mindfulness in reducing stress levels in individuals. ANOVA can determine if there are significant differences in mean stress reduction scores between the techniques. Then environmental pollution levels. Imagine you are conducting an environmental study to assess the impact of 3 important pollution control methods on air quality. ANOVA can be used to determine if there are statistically significant differences in mean pollutant levels among the 3 methods. In all these examples, ANOVA helps researchers assess whether there are significant differences in the means of multiple groups, which are valuable for making informed decisions. And these are dependent variables. If ANOVA indicate that there are significant differences, post hoc tests can be used to identify which specific group differ from each other. ANOVA is a versatile tool that plays a crucial role in various fields of research and decision making. Then explanation of stress related example. Let's explore the stress related one. Suppose you are a psychologist conducting a research study to investigate the effectiveness of 3 different stress reduction techniques: meditation, exercise, and mindfulness practices. Your objective is to determine if there are statistically significant differences in the mean levels of stress reduction achieved by individuals practicing these techniques. We will be collecting data. You recruit a sample of 100 participants who report experiencing high levels of stress in their daily lives. Participants are randomly assigned to one of 3 groups. Group A practices meditation for 30 minutes daily. Group B engages in regular aerobic exercise for 30 minutes daily. Group C practices mindfulness technique for 30 minutes daily. Each participant's baseline stress level is measured using a standardized stress assessment tool before they start their assigned technique. After 1 month of practicing their respective technique, participants' stress levels are measured again using the same assessment tool. Hypothesis. Your hypothesis for this study could be null hypothesis. There are no significant differences in mean stress reduction levels between the three groups: meditation, exercise, and mindfulness. An alternative hypothesis: at least one of the groups has a significantly different mean stress reduction level compared to the others. You conduct an analysis of variance ANOVA on the data to test whether there are significant differences among the three groups in terms of stress reduction levels. Interpretation of results: if the p-value of the ANOVA test is less than a predetermined significant level 0.05, you reject the null hypothesis. If you reject the null hypothesis, indicate that at least one of the stress reduction techniques had a significant different effect on stress reduction compared to the others. Post hoc tests: if ANOVA shows that there are significant differences, we can follow up post hoc tests for analysis like Tukey's, I'm not sure about the pronunciation, DUKEYS Bonferroni technique to determine which specific pairs of groups are different from each other. For example, you can identify whether meditation was more effective than exercise or mindfulness in reducing stress. Based on the study results, you can conclude whether one of the stress reduction techniques is more effective in reducing stress levels, and you can provide evidence to support your findings. This is an example demonstrates how ANOVA can be used to analyze and compare the means of multiple groups in the context of a psychological study on stress reduction techniques, helping researchers draw meaningful conclusions about the effectiveness of different interventions. And how to conduct ANOVA in SPSS, very detailed explanation. In this example, we will use a hypothetical data set. We want to compare the effectiveness of three different stress reduction techniques: meditation, exercise, and mindfulness on reducing stress levels. So open your data file, launch SPSS, and open the data set that contains your stress reduction data. Then define your variables. Ensure that you have defined your variables appropriately in SPSS. You should have a variable for the stress reduction technique, categorical variable, and a variable for the stress reduction levels. That means a numerical value. Then run the ANOVA analysis. Go to analysis in top menu, select general linear model in the drop down menu. In the general linear model dialog box that appears, choose univariate. Since we are analyzing one dependent variable, that means stress reduction levels. Set up the ANOVA. Move your dependent variable stress reduction levels into the dependent variable box on the left. Move your categorical independent variable stress reduction technique into the fixed factors box on the right. Click the options button in the general linear model dialog box. In the options dialog, select descriptive statistics to get means and standard deviations for each group. Check homogeneity of variance test to check the assumption of equal variance. Check continue to return to general linear model dialog box and define contrasts. If you have specific hypotheses about the differences between groups and want to set up custom constraints, you can do so in the contrast tab within the general linear model dialog box. This step is optional. Then perform the ANOVA. Click the OK button in the general linear model dialog box. SPSS will run the ANOVA analysis and display the results in the output viewer window. Then interpret the results. In the output viewer, you will see various tables, including the descriptive statistics table, which provides means and standard deviations for each group, and the homogeneity of variance table, which checks the assumptions of equal variance. The test between subjects effect table, which contains ANOVA results, check assumptions. Depending on the results, you may want to perform post hoc tests. Tukey's HSD to identify which groups differ significantly. Then report the findings. Write a report or present the findings from your ANOVA analysis, finding any significant differences between groups and the effect sizes if relevant. Remember that interpreting the data correctly and making informed conclusions are crucial aspects of the analysis. Additionally, you may need to consider assumptions and post hoc tests depending on your specific research questions and database. Next topic is about chi-square test. So the chi-square test is a statistical test used to determine whether there is a significant association between two categorical variables. It is employed to assess whether there is a relationship or dependence between the variables. And it's particularly useful when you want to investigate if the observed distribution of data offers significantly from what you would expect by chance. Here are some common scenarios and examples where the chi-square test is conducted. Market research example, product preference. Imagine you are conducting a market survey to understand whether there is an association between age groups, young, middle aged, and elderly, and preferred product choices, product A, product B, and product C among consumers. The chi-square test can help determine if product preferences are independent of age groups or if there is a significant association. And medical research example, disease and risk factors. In a medical study, you want to investigate whether there is an association between smoking status and the development of a specific disease, lung cancer. Chi-square test analysis can help determine if there is a significant association between smoking and disease incidence. Then education examples, exam performance and study time. Suppose you are researching whether there is a relationship between the amount of time students spend studying, categorized as low, moderate, or high, and their exam performance, pass or fail. A chi-square test can help assess if there is a statistically significant association between study time and exam outcomes. Then quality control example, defective parts and machine type. In a manufacturing setting, you want to examine whether there is an association between the type of machine used for production and the occurrence of defective parts. Chi-square analysis can help determine if machine type is related to the rate of defects. Social science example, political affiliation and voting behavior. In a political science study, you might explore whether there is an association between individuals' political affiliations, Democrat, Republican, Independent, and their voting behavior in an election, voting for candidate X or candidate Y. The chi-square test can be used to assess if political affiliation is associated with voting choices. In all these examples, the chi-square test is employed to examine the relationship between two categorical variables. The test helps researchers determine whether the observed data deviates significantly from what would be expected under the assumption of independence between the variables. If the chi-square test indicates a significant association, it suggests that the variables are not independent and there is a relationship worth investigating further. So let's explore a chi-square test example related to stress levels and job satisfaction. Scenario, imagine you are an HR manager in a company and you want to assess whether there is an association between employees' job satisfaction, categorized as satisfied, neutral, or dissatisfied, and their stress levels, low, moderate, or high. Data collection. You distribute a survey to all employees asking them to rate their job satisfaction and stress level. Employees rate their job satisfaction as either satisfied, neutral, or dissatisfied, and their stress levels as low, moderate, or high. Null hypothesis, there is no significant association between job satisfaction and stress levels among employees. Alternative hypothesis, there is a significant association between job satisfaction and stress levels among employees. Chi-square test, you conduct a chi-square test to analyze the association between job satisfaction and stress level. After collecting the survey responses, you create a contingency table that cross tabulates cross job satisfaction and stress level. This is a code for that. We don't need that. Interpretation of results, you perform a chi-square test in this contingency table which calculates the chi-square statistic and its associated p-value. If the p-value is less than your chosen significance level 0.05, you reject the null hypothesis. It indicates that there is a significant association between job satisfaction and stress levels. Based on the results, if you find that the p-value is less than 0.05, you can conclude that there is a statistically significant association between job satisfaction and stress levels among employees in your company. You may further investigate the nature of this association and take appropriate action, such as the addressing sources of stress to improve overall job satisfaction. Next point we will be learning tomorrow. Thank you for listening.